Hi everybody, the goal of this part of the talk is to show the dynamics of a laser powder bed system, metal additive system. So I'm going to show a couple parts. The first part I'm going to show an actual video of laser hitting the powder just so you can see how that looks in real time. Then I'm going to show a simulation of the interaction between the laser and the powder bed and show all the dynamics. I'm going to run that simulation 1,000 times slower than real time. Then I'm going to run it 20 times slower, 2 times slower, and then try to run it real time, just so that you can get a feel for what the dynamics are, how fast they are, and then how quickly we have to sense those dynamics to be able to capture those. Okay, here is the lasers in real time running across the part, just so I get a feel for how it looks in real time in real life. Now here's the simulation. The blue is the powder bed metal. The laser beam is coming down from the top, just starting to melt the powdered metal. You can see it's setting up a flow, the laser traveling from left to right. The flow is melting in the front side. You're getting flow down through the back side. This simulation has convection, evaporation, melting, solidification, lots of the physics. Has the wetting angle, surface tension. Then also, it not only impacts that layer, it also impacts the layer below. So you can see the depression, you can see pores. We're trying to develop strategies to reduce the number of pores, of course. Then we'll play out this simulation for a little bit further so you can see the full dynamics and the solidification after the laser stops. The thing to keep in mind is anything that's moving quickly here, when you're running the simulation 1,000 times slower, you can imagine when you run in real time how quickly those move through. So now the laser's turned off, the metal's turning from liquid, which is the red, into solid, which is the green. And one of the key here is the rate of cooling impacts the material properties. So now we run it 20 times slower, 2 times slower, then we run it real time. And the idea to capture is, in that real time, all those dynamics are actually happening. What we've seen is that those dynamics are on the order of about 1 kilohertz. For us to be able to see the details of what's going on, we have to measure somewhere on the order of 10 to 20 kilohertz. So that sets up what is a challenging ability to read those in and process those and do analytics on those types of signals to be able to see all of those details that are actually happening.